Welcome to Math 1324, Section 8.1. This is our first section looking at probability. Whenever we talk about probability, what's important to talk about is S, which is the sample space. The sample space is a set, and it contains all the outcomes that could occur. When you see N of S, that's a count of how many things are in S. So suppose I'm going to flip a coin. And when I flip the coin, what can happen? Well, I can get heads or tails. And so the number of items in set S is 2. We usually let the capital letter E denote a particular event within the sample space. And N of E is how many things are in E. And so we define the probability. So we have to define this number in some way. And so we define the probability of an event is the number of things in the event divided by how many things are in the sample space itself. Now, E is always a smaller set than S. So you can see this ratio can never be any bigger than 1. And similarly, since it's a count of how many things are in there, the smallest count we could ever get would be 0. So the probability of an event is always a number between 0 and 1. 1 essentially being that the probability is a 100% chance. Okay, so we can't have any negative numbers and can't have any numbers bigger than 1. Now on our first question in the homework, they're going to give us two probabilities. The probability of E is 15/16 and the probability of F is 11/12. And the question is, well, which one is more likely to occur? Well, remember, the biggest we could ever have would be 1, which is 100%, and that's the most. So the question becomes, which one of these fractions is the closest to 1? So let's see, 15/16 is 0.9375, and 11/12 is 0.9166. So looking at the decimal representation, clearly 15/16 is a bigger fraction. Therefore, event E has a higher probability and is more likely to occur. In question 2, we have a circular spinner. So essentially, I've got one of these circle things. I've got a little nail in the middle, and then I've got one of these spinners that you can hit and it spins around in a circle. Now this circle is divided into 13 sectors of equal area. So that's your sample space, the 13 sectors. Now there are 3 red, 4 blue, 3 yellow, and 3 green. And so the question is, what's the probability that I hit the spinner and it lands on blue? All right, well, let's see. How many blues are there? There are 4 blues. How many things in S? 13. So the probability that the spinner lands on blue is 4 out of 13, because that's the number of things in E divided by the number of things in S. Now in question 3, we have a standard 52 card deck of playing cards. So if you're not familiar with playing cards, you can Google and get a picture of these 52 cards. A brief introduction. You're going to have 26 red cards and 26 black cards. So 26 red and 26 black, because it adds up to give me 52. Of the red cards, there are 13 diamonds and there are 13 hearts. These are all red cards. In the black cards, you got 13 clubs and you have 13 spades. Okay, so the 26 break up into 13 clubs, spades. The reds break up into diamonds and hearts. Inside each one of these, the numbers go 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have a jack, a J, Q for queen, K for king, and A for ace. So each one of these 13. And so what is our question? There are 52 playing cards. What's the probability that I close my eyes and I pick out a king? Well, how many kings are there? Well, there's a king of hearts, a king of diamonds, a king of clubs, and a king of spades, so there are 4 in that event. And so the probability is 4 out of 52, which reduces to 1 out of 13. Now in question 4, we want to find the probability that I reach into this deck of playing cards and I get a red card or I get a 4. Well, let's think about this. How many red cards? There's 26 of them. And how many 4s? Well, there's 4 of those. There's a 4 of diamonds, a 4 of hearts, a 4 of spades, and a 4 of clubs. So you might think, well, let's just add them all up. I got 26 out of 52, and I got 4 4s, so 4 out of 52. And that would give me 30 over 52. But the problem is I double counted 2 cards. The 4 of hearts and the 4 of diamonds. I counted them as both in the diamond and the red category, and I also counted them in the 4 category. So since 2 cards were double counted, I have to subtract that off, and so I get 28 out of 52, which reduces to 7 over 13. In question 5, we have our standard 52 card deck. They're talking about the 4 card suits. Okay, so there's these 4 13 card suits: diamonds, hearts, clubs, and spades. Diamonds and hearts were red, clubs and spades black. Okay, and they're telling us a lot about all the cards. They should have included that the very first of the problem set. Anyway, what's the problem? What's the probability that I pick a black queen of diamonds? Well, we first think, well, black queen, there's 2 of those, right? Because there's a queen of spades and a queen of clubs. But then they say the black queen of diamonds. Well, diamonds are red cards, so this is just not possible. And so the probability of that occurring is 0. In question 6, we have a family with 11 children. So what's the probability of having all 11 girls? All right, well, let's see. First off, let's see if we can solve a simpler question that we can draw. What if I had 3 children? Then I could have, on the first child, I could have boy or girl. So this represents the first child. This next level represents the second child, and the last level is the third child. So you see, I could have a boy followed by a boy, or I could have a boy followed by a girl. Girl, boy, girl, girl. And so if you trace this out, there's only one possibility of getting girl, girl, girl. So similarly with 11 children, there's only one possibility of having all 11 girls. So the number in your sample space is 1. Now for 3 children, think of it as 3 boxes here. Each box has 2 outcomes. So 2 times 2 times 2, which is 2 cubed, is 8. So in our case, with 11 children, it's going to be, this number is 2 to the 11th power. And since there's only one way to get all girls, it's 1 over 2 to the 11th. All right, question 7, we have a keypad. We have some buttons labeled 0 through 9, so there's 10 of these buttons. We want to guess a 3-digit code. So think of it again as 3 boxes. Now they don't tell me anything about the code, so there can be repeats, order can matter. So I might have let me just show you some examples. I could have a code that looked like 000. I could have a code that looked like 932. So these are just example codes. I could have 888. So all of these, the question is, well, how many of these are there? Well, each box could be a button 0 through 9, and since you included 0, there are 10 of those. So you really have 10, 10, 10, or 10 cubed, which is 1,000. And so what's the probability that I guess the correct one? Well, that's the important part. There's only one of those. And so the probability is 1 in 1,000.